Hi, welcome back to the channel. So in this video we are going to see machine learning NPTEL courses answers of week 2. Okay, first question. So this is for the 2025 batch of July courses exams. Okay, so the exam is in October, November I think. Okay, so state true or false the first statement. Typically linear regression tend to underperform compared to k nearest neighbor algorithms, KNN algorithms, when dealing with high dimensional input spaces. So here what is the correct answer? The correct answer is false. It is false. Linear regression tend to underperform. No. KNN algorithms always underperform in high dimensions. Okay. Linear regression is going to be more efficient in high dimensions. Hence, it is false. What is false? Linear regressions will not underperform compared to k nearest. Okay. Second question. This is the table they have given. Given the data set, find the univariate regression function that best fits the data sets they have given. So x value and y value they have given 2, 3, 4, 10, 5.5, 6.5, 9, 18.5. So they have given 4 equations. So here the trouble is you should calculate all 4 and it is going to be time consuming. So they have given 2 marks here, right? So now for this we will take the table, right? So to find the line, what is the line? Y is equals to mx plus b. Okay, so we'll consider the first option. What is the first option? 1 into x plus 4. So here y is 1 into x plus 4. We will write x value is 2. Where is 2? 2 is given here. You can closely observe. 2 is given, that is the x value. So that is what we have written here, 2, right? So later y value is 6. How y value is 6? We have considered here. You can substitute 1 into x plus 4. What is 1 into 2? 2 plus 4 is 6. So x is 2, y is 6, right? How we are going to calculate the error now? Error is y minus y. What is y? This y, capital Y, minus this y, small y, and it is square. If I do that, what is the result I will get? 0.25, right? So you can closely observe for x2 and y6 we are getting 0.25. Similarly, you can observe the next one for x3 and for y7 we will get the error 0.25. Similarly, for x4 y8 we will get 1, x10 y14 we will get 20. So we should add this sum of the squares. Sum of the squares we will get 21.75 for the option number 1 for this. So similarly we should check for the remaining 4, right? So the remaining 3. So which is going to be the minimum sum of squared errors? That is the answer. So instead of doing for all, now I already calculated the third option. So you can go for the third option, 1.5 x plus 3. For this we will substitute this x is 2, y is 6, x is 3, y is 7.5, x is 4, y is 9, x is 10 and y is 18. For this the error values will get like 0.25, 1, 0, 0.5. If I add the sum you will get 1.5. So it is the minimum value, sum of squares you will get, right? So that it is going to be the correct answer. You can cross check with the 2 and 4. So I have written that 2 and 4. So here you will be having 2 value is 16.5 and option 4 is 6.75, right? So for this the correct answer is this. For this you will be having a very minimal value. So that is the way of doing. Find the univariate regular function that best fits the data is minimizes the sum of the squared errors. Okay, we can go through one more time this answer, I will get it, otherwise this video will take some time. So we should take the third as the answer, right? So next third one, given training a data set of 500 instances with each input instance having 6 dimensions and each output being a scalar value, the dimensions of the design matrix used in the applying the linear regression to do this is, the answer is 500 into 7. How is? They have given that x individual variables features, the number of instances they have given is 500. Okay, so that is nothing but the number of rows, right? So the number of dimension features they have given is 6. These are the number of rows or the features, the dimensions are 6, right? So we'll write the intercept form. The intercept form is y is equals to beta naught plus beta 1 x1 plus beta 2 x2 up to beta p xp. So here beta naught is the intercept. So in the design matrix, x corresponds to 1 column of intercept and 6 column of features. So we should add the total number of columns 6 plus 1, that is 7. So it is 500 into 7. That is the correct answer. Fourth one, assertion and reasoning they have given. In the assertion, binary coding is usually preferred over one-hot encoding to represent categorical data. That is color and gender they have given. Reasoning is binary encoding is more memory efficient when compared to one-hot encoding they have given. Right? The correct answer is A is false but R is true. Why A is false? We will see that. Right? Why R is true? We will see that. Okay. So here I have written here wrong. So kindly make a correction. Here both A and this is not the correct answer. A is false, R is true. Okay. So for n categories, we will be having log n base 2 bits for binary encoding. For n categories, n bits for one hot encoding. For binary, we will be having log n to the base 2. For one hot encoding, we will be having n, right? So they have given that binary encoding is efficient, right? So first one, then compared to one hot encoding, and with respect to the memory and more efficient they have spoken, right? So here if you consider with respect to the memory, so I will consider here this part, you can read this. When considered binary encoding is with respect to the memory efficient, it is better. Binary encoding is better compared to one hot encoding, but one hot encoding is preferred over binary encoding. Binary encoding is not usually preferred over one hot encoding to represent categorical data like colors and genders. Okay, so which is preferred? One hot encoding is preferred. So statement A is false, B is correct. It is about memory, no issues. Okay, so that is a correct answer. For fourth one, A is false, R is true is the correct one. For fifth one, select the true statement. What is the first statement? Subset selection methods are more likely to improve test error by only focusing on most important features and by reducing variance in the fit. Okay. So here it is about testing error and it's about training error. Okay. So correct one is first one. It is about the test error, more likely to improve test error, not the training error. You can look at the second option. First and the second both are same except it is testing and it is training, right? So it is about the testing error. Okay. So subset selection methods are more likely to improve test errors by only focusing in the most important features. Okay. What is the goal? To sacrifice the train error for significant improvement in the test error. So first one is the correct answer. So obviously third and the fourth are wrong because third is consisting of both train and test. No, it is not like that. It has to sacrifice the train to improve the test. Okay, and fourth one is obviously wrong. Sixth one, rank the three substrate selection methods in terms of computational efficiency. So with respect to computational efficiency, first will come is forward. What is that? Forward stepwise is first one. Next, second one is forward stage wise. Third one is best subset, right? This is greater than this is greater than this, right? So here the correct option in that case is second one, forward stepwise is greater than forward stage wise, regression better than best subset selection. It is with respect to what? Computational efficiency, right? Next, seventh one, choose the true statement from the following. Multiple correct choices. So multiple correct are there here. So what is the correct answer? Ridge regression, since it reduces the coefficients of all variables, make the final fit a lot more interpretable. So it is a wrong one. Lasso regression, since it doesn't deal with the squared power, is easier to optimize than ridge regression. Wrong one. So it is about the stability and it is about the interpretability. But look at here, ridge regression is more stable optimization, right? So compared to lasso regression, and lasso regression is better suitable for interpretability than ridge regression. Okay, you can observe here the first and the fourth. Look at the first and the fourth. Ridge regression is lot more interpretable, and what is the last one? Lasso regression is better for interpretability. So here the correct answer is lasso regression and re- third and the fourth, right? So instead of saying, so what is the correct is third and the fourth. Ridge regression is most having a most stability. Lasso regression is better suitable for interpretability. Okay, eighth one. So here, how to see the eighth one, the last question. Here also it is having 2 marks, right? So 1 second. Okay, so here the question is about which of the following statements are true. Let xi and ith be the data point in a data set of n points. Let v represent what? First principal component analysis. First principal component analysis. Okay, so out of these 4 options, which is representing the first principal component? So here we should know this. What you should know? Maximum variation will give the first principal component analysis. Minimum variation will give the last principal component analysis. So out of this 4 statement, the first option is giving about the maximum variance, right? So this is speaking about the variance. Okay, so now that is the first one. Then what about the last one? So principal component vectors are scale dependent. Look at this. The resultant vectors obtained when performing PC on a dataset can vary based on the scale of the datasets, right? So that is why first and the fourth are correct. Why second is wrong? Because it is about the minimum. So minimum is about the last principal component analysis. It's not the first. They are asking about the first now, right? So and also this is wrong. Performing PCA is just for the better numerical stability. No, it is wrong, right? So this is a week 2. This is the week 2 NPTEL examinations of which subject? Machine learning, right? So here it is 2025 July started. The courses are started at July. Think the exam is on the November 15 or October 15 of 2025. It's a 12-week course, right? So these are the week 2 answers. So we have uploaded week 1 and week 2. So go through the channel so that you will get it. Okay, under the playlist I will give this machine learning all 12-week answers with some explanation up to the knowledge. Suppose if I'll try to give all the correct answers. Suppose if the wrong answers is given, so I'll put it in the description about the correct answers. You just go through a description as well as the video. Okay, thank you. We will see in the next video. Stay tuned to this channel. Click on the bell icon for the latest notifications. So in my channel I have already uploaded the deep learning and the Python week wise answers, also the NPTEL. Anybody interested, you can go through that, or you can just share the videos. Thank you. We'll see in the next video.